Hello, this is my assignment. So I'm gonna start right off the bat now. Not gonna waste any time because I think it's gonna be long. So first we will answer the exercise number 1. See here, you have a graph here. You have a graph. Okay, let me zoom it. Oh no. Here's the graph. It's from the origin. There are two lines. One is a straight line. The equation is y is equal to x, and 1 is 5x minus x squared. And you will have the shaded part, and you have to find the area. Now, we know that the other point is 4, 4, and this is from the origin, which is 0, 0. So we will write the two equations. Then y is equal to x. And then we know that from here to here, you will have a domain of x from 0 to 4. Here, you'll have this from here to here. And now, we're gonna have the area, which is equal to the first one minus x, the second one. Now, we will find the integral of this equation. So area is equal to the integral of, I know that is 0 to 4, so minimum, maximum, 0, 4, and then it will be, we see here that 5x and minus x, so we're gonna have 4x minus x squared, and then don't forget the dx. After that, we will calculate it. We will have area is equal to here 4x. So the derivative of this is 4x raised to 1 plus 1, so squared over n plus 1, 2. You have 4x squared minus here it will be 2 plus 1, so cube, n plus 1, so 3. And then we will evaluate 0 to 4 here, this one. We will evaluate this here. And now we will have the area here. The area, as you can see, is just substitute. Here we know the 4, so this will be cancelled. Cancelled will just be 2. So area will be 2x squared minus x cubed over 3 on 0 to 4. Now we're gonna substitute the 4, so we'll have 4 squared minus 4 cubed over 3, and then we will get, oh, this is minus 0 because of course here the 4 and then the 0. After this, we will get, here is, let me just use my calculator. 2 times 16. Of course, we have 32 minus here. 4 cubed is 64 over 3. Then we can simplify it. We have 32 minus 64 over 3, which is 32 over 3. It's the area of this equation. Okay, moving on to the next. Okay, now here's number 2. Just like what we did in number 1, we have from the origin and 6 to 12. So we're gonna have 0 to 6, just like what we did the last time. Then again, we will have two equations. Here's the first one, x squared minus 4x. The second one is y is equal to 2x. Okay, so we will subtract this again. So we will have the 2x minus x squared minus 4x, and we will have 2x minus x squared plus 4x, and then we have the minus x squared plus 6x here. Now we will find the derivative of this equation. So the area is equal to the derivative from 0 to 6 of the value we have here, minus x squared plus 6x, don't forget the dx, and then we will solve its derivative. So here it will be 0, no, this will be this 6 the minus x 2 plus 1, so 3, 10 plus 1 3, and then plus the 6 1/2 x squared. You see, because x is raised to 1, so we have 2 here, because n plus 1, and then here n plus 1 2, so we get this one 6x squared over 2, and we can cancel this out. This will be 3. You understand? Yes, of course you do understand. Now we'll have 3x squared minus 1/3. Oh no, we'll make this so it's easier to visualize, like this, and this will be 6 0 and 6 to 0. After that we can just substitute. Okay, this will be equal to 3 6 squared minus 1 over 3 6 cubed. See, minus 0, because when you substitute 0 it will just be 0 and 0. You know that, right? Of course you do. And now we will have 3 6 squared 36, and then 6 cubed is 216 over 3 minus 0. Then we will compute this one. This is equal to 108, and this is minus 72. We'll have 36. It's the area of this shaded region. Area, okay, 36 units. Okay, just like the 2 exercises we did, we will find again the 2 equations. Okay, now here we have 3 equations. Y is equal to 1. We have a value for y, which is 1, and x is equal to the square root of y, and x is equal to y squared minus 1. Here you can see y squared minus 1. We can now we have a value of y here, which is 1, so we can easily substitute it. And now we will first we have to subtract all these equations so we can have one equation. So it will be square root of y minus this one, y squared minus 1. This will be equal to square root of y, then distribute the negative sign, so minus y squared plus 1 here. Now we have this, and now we know that y is equal to 1, so here x is equal to square root of y, y is equal to 1, so it's 1. So the region we will look is from 0 to 1. So we will have the area is equal to the integrals from 0 to 1. Then we have the value, no, the equation y squared plus 1 dy, and now we will find its derivative, antiderivative I mean. Here 0 1, here we will have square root of y. We know that if it's square we can identify it like this, as per the rule of antiderivatives. Minus y squared y 2 plus 1 3 over 3 plus y. That's the antiderivative. And now we will substitute the values. So substitute the 1. So 2 over 3 times 1, 3 over 2, minus 1, raise 1 cube, 3 plus 1. And we know it's minus to this value is 0. So 0, this is 0, 0. We get 0, 0, 0. Then we will have 0 here. Alright. And here we will compute for the value. So this is equal to 2/3 minus 1 over 3 plus 1. Then just normal LCD for the 3 values. We will have 2 over 3 minus 1 over 3 plus 3 over 3. Just simple math. We get 2 minus 1 plus 3. We get 4 over 3. So the area is 4 over 3 units. Next. Okay, looking back to this, I made a mistake. I think I told you that we get the 0 to 1 because this is 1 and this is 1. No, we get 0 to 1 because we're in the y axis. From here 0, the origin, to 1 here, which is the top part. That's my clarification. I'm very sorry for my mistake. I stand corrected. Thank you. Now moving on to the next problem. So here again, another problem like the previous ones. Now we have two equations as you can see, and we will find the shaded region here. Now, first equation is x is equal to y squared minus 4y. And the second one is x is equal to 2y minus y squared. Now, we have this equation now. You know what to do. Now first, based on the graph, we'll compare in these equations which one is greater of value. And if we substitute certain values of y here in 2y minus y squared and y squared minus 4y, we will just do this on your own. We can deduct this, that 2y minus y squared is greater than y squared minus 4y. So this will be the one we will subtract it to, just like the ones we did before. It's a greater of its degree. Oh, actually it's the same degree, but when you compute the value you will know. Now we will have the equation of 2y minus y squared minus y squared minus 4y dy. Here you can see the two equations. So no, this is for later. If we simplify it, we can see that you just no, this is minus here in the middle. Let me do it again. I'm sorry. I'm just a human. I make mistakes. 2y minus y squared minus y squared minus 4y. Here we have this. There's the minus to this. And now we can simplify it. Distribute the negative sign and you get 2y plus 4y, and it will be 6y minus 2y squared. Now we have this, so we will have integral. Now here it's from the interval is 0 to 3, y interval 0 to 3. We have this, so this will be 0 and 3. Now we have this 6y, just input this, minus 2y squared. Oh, this is the area, of course. 2y squared, oh I'm sorry, bracket, and then dy, of course, and then just do the integrals here. 0 minus here, you know that it's 2y squared, so 2 plus 1 get 2y cubed, 2 plus 1 and plus 1 3 here, and then we'll have plus here from the 6 we get a 6y squared over 2, and okay, you will simplify this, you will get 3. Okay, now we have the area is equal to the integral 0 of our equation 2y minus 2y cubed over 3 plus 3y squared. Okay, then substitute the value again and again. So we'll have here the area is equal to here minus 2 3 cubed over 3 plus 3 squared. And here we will, oh yeah, before I forgot, this is minus 0 of the 0 0, so just 0. Now area will be equal to 3 here, 3 squared minus 2 3 squared, and now we substitute the value here. We get 9, 9, then 3, then minus 2, then times 9, so we get 9 units. The area is 9 units. I hope you get that. Of course you do. And now we move to number 8. Now here we're given equations f of x and g of x here. And we will approximately draw the illustration of it via graph. And now we have concluded this graph. F of x is equal to x plus 4, which this line, and g of x is a parabolic x squared minus 2x. And now we will have, again, from like before, two equations, x squared minus 2x, and then y equal to x plus 4. Now we know that this equates to 1, and we have we can subtract it again, the higher to the lower degree. If we move is equal to both to y, so it's just the same. We will just move it like before. So x squared minus 2x minus x plus 4 is equal to 0. And now here we will have values of x. As you can see, we will have a quadratic equation. So here x squared minus 3x minus 4 equal to 0. Now we can use some quadratic techniques to find the values of x. And here, this is 4, so what can you multiply? What can you divide it to? That if you add it, it will be minus 3, so it will be negative 4 and positive 1. Just pause the video if you gotta take time to process this math. And then we have the value of minus 1 and 4 of x. So we now have the interval, right? Interval of it. Now we will find for the integral again of the area, because we have to find the area, of course. So minus 1 to 4, and we have the equation x plus 4 minus x squared plus 2x dx, and this is equal to minus 1 here. Simplify it, 3x plus 4 minus x squared dx. Simple. And then do the derivative. Here, 3x. It's 3x plus 1, so 2 over 2 plus 4x. Simply 4x. Minus x cubed over 3. Just like what we did before. Here, 4 minus 1. Now, we gotta substitute the values. So here we have 3, 4 squared over 2 plus 4 times 4 minus 4 cubed over 3. 4 cubed over 3. Then minus, substitute the minus 1. Here we have 3 minus 1 squared over 2 plus 4 minus 1 minus 1 cubed over 3. Now, just pause the video if you have to, but we will quick maths this. Here we get 4, 16, so 16 times 3 over 2, we get 24, minus here, 4 times 4, we get 16, no, this is plus, minus 4 cubed, 64 over 3, 64, yeah, right, minus 3 over 2, because this is squared, so it will be positive 1, minus 4, right? That's right? Minus 4. Yeah, before we forgot, we have a parenthesis here, so distribute the minus. This will be a positive 1, because it will be minus here, and distribute the negative sign, minus again. And then we have plus. This is minus 1 over 3 here. Easy. And then we will just use the calculator and solve this. 24 plus 16, 40, and here all of this based on the calculator is 37 over 2, and if you compute this, 40 minus 37 over 2, you get a value, oh, I'm sorry, we get this minus sign here, so it should be wrong, and we will have, here we'll have minus 115 over 6, and when you 40 minus this fraction, we get 125 over 6 equal to the area of the shaded region. Next. Okay, now we're in problem number 14, right, mate? And here again we have two equations. Y is equal to x squared. This is the, let's denote this f of x, and this is the g of x. We have these two equations. Now we have, write it again, x squared and y is equal to 4x minus x squared. Here we know this point based on the graph of this parabola. Get this point, the maximum value of it will be its coordinate is 2, 4. So from 0 to 2, this is 2, this is 4, it will be our interval 0 to 2. Now we have this, so it's the same again, and then subtract. We will find the equation 4x minus x squared minus x squared. So we have 4x minus 2x squared, and we can verily simplify this as to we can put out 2x outside, then we have x minus 2. So here, find the values of x. just like this one, from looking at it, 0 to 2, because here, if you make this 0, it will be 0. If you make this 2, it will make it 0. So 0 and 2. That's our interval. Now we will solve for the area again. Integral from 0 to 2 of our 4x minus 2x squared dx. Of course, don't forget that. Okay, this is quite easier than before, so we can get here 4x, of course, x 1 raised to 1, so this will be 2 over 2. Cancel this, it will be just 2 minus here 2 x, it's in squared, so plus 1 cubed over 3. Now we have this. Next step is to substitute the values. So we have 2 squared minus 2 cubed over 3 minus is 0. Here, if it's 0, it's 0. If it's 0, if x is 0, 0. So minus 0 easily. And now solve for a. This will be 2 squared 4, 2 times 2, 2 times 4, 8 minus 2 cubed times 2 over 3, 16 over 3. So if you calculate this, multiply this by 3, so it will be 32 over 3 minus 16 over 3, 8 over 3. Alright? No, I mean 24, yeah, minus 16 over 3, 24 over 3, minus 16 over 8, yeah, sorry, just a human. This is our area. Quite the easiest so far, right? Might? Alright, I hope you agree with me, eh? Okay, now we had f of x and g of x here as y raised to 4 is equal to x and y is equal to square root of 2 minus x. If we substitute some values, we can find the graph, the approximate graph. It doesn't matter because just an approximate illustration, and we will be focusing on just the numbers here. We have two equations, y 2 minus x and x, y raised to 4 here. If we if we simplify y, we can turn this into y 4th root of x. Just some high school math, or maybe elementary, it doesn't matter. Now here we will equate it to each other, just like before, to find x. So y raised to 4 from the two equations plus y squared minus 2 here. We square this, so we have 2 minus x. Now we're looking at the x here. It's equal to 0. We will be looking for the y value, I'm very sorry. So we have this equation. Now from here we can simplify this even further to y squared plus 2 and y squared minus 1, because you see y raised to 4, and do some maths. You can pause the video and you will see here. If you multiply this, it will just be like this. And here you can also simplify this even more. The y squared minus 1 into y plus 1 and y minus 1. Of course, we know this principle is very simple principle. Now we will see that y squared plus 2 times let me write y squared plus 2 quantity y plus 1 and y minus 1. Here, see, if y is 1, 0, y is -1, 0. That's it. It will make this 0 because this will never get 0 in this equation, so only depends on this. We'll know that y is equal to 1 and -1. All right, so before we forget, this is in the fourth root, so the fourth root of 1 and -1 is the same value, just 1, even though it's negative. Fourth root of it, just no, I mean not this, I meant 1 and -1. Yeah, this one, right? When you raise to 4, not fourth root. I'm sorry, my mistake. See, I'm having mistakes even while doing this tutorial, so yeah, maybe I should improve, but yeah, here it is. Okay, now we have the value of y, which is 1. Yeah, we get this, right? So, interval 0 to 1. 0 to 1, that's our interval. Now, the area is equal to the integral from 0 to 1 of 2y minus y squared minus y raised to 4 from our formula. No, what? 2, just 2, yeah. Sorry, dy. I should, yeah, never mind. Here, 2. Antiderivative 2y. Y squared, y cubed over 3, y raised to 5 over 5. Yeah, that's it. Now substitute 1. 2, 1 minus 1 cubed over 3 minus 1 raised to 5 over 5. We get 2 minus 1/3 minus 1 over 5. Right? Oh, of course, don't forget the -0 here. Of course, is in 0. So we get the very value of it, 2 minus 1 over 3 minus 1 over 5. And simple LCD, least common denominator, or just some calculator, very easy. We get 22 over 15. That's the area. All right. Okay, now my flash is off because battery too low. It said no, it doesn't matter. I'm charging now. Here, first one, we have a graph here, velocity time in minute graph. We have this car, which is A and B. Here, point C, they intersected the velocity and time. As you can see, okay, I stand corrected in the book. This is A and this is B. Yeah, sorry. Here we can see that the distance traveled is the distance over time graph is the antiderivative of the velocity time graph. So we can see here the A has a greater area that its scope than the B, and from the starting point it has a better velocity than the B in T minutes, 1 minute to be exact. So here we can say that A is ahead in the span of 1 minute. You can see in the graph here, this is the A and this is the area of the two lines here. See, it's greater than the B at the point of C. 1 minute. Okay, next. Here, the next question, question B. What is the meaning of the area of the shaded region? As we said in the A, where we based our answer, shaded region here. Again, I will repeat. We know that X time graph, based on the formula of velocity and distance and time in physics, xt graph, when you find the derivative of this, you get the vt graph, velocity time graph. So antiderivative of the vt graph, the integral of vt graph, is the distance times time graph. So we can see here in the shaded region that the area of the curve will represent the xt graph. So the distance from car B to car A, or the distance of car A to car B after 1 minute, in the span of 1 minute, is the shaded region. Shaded region is the distance of the two cars to each other, knowing that A is ahead of B after a given point of time, which is 1 minute. All right, that's for B. Here in the next question, question C, which car is ahead after 2 minutes? Now, looking at the graph, here is 2 minutes, and we can see here this region is the difference in the distance of B and A. So we can see if we're talking about 2 minutes, we know that in the mark of the first minute, A is ahead of B. And now here, looking at the two, by looking at the tangent, the slopes of it, the B is gaining speed, even though in 2 minutes the B will have a better velocity than A. We can see the tangent slope is from here is greater than here. So it means in just a span of a minute and a minute, from 0 minute to 1 minute, and from 1 minute to 2 minutes is the same interval, which is a minute, just one. We will see that what A traveled is greater than what B traveled after the mark of the first minute. So we can say that A is still ahead of B. But from this, the graph will go on, and we can justify here that B at some point will catch up to A and be ahead of it. Last question, D. Estimate the time at which the cars are again side by side. So how do you think can we estimate this? Here's what I think. We know that the area of this A under B over B is the displacement, right? So we have to make the B get the same magnitude of area as this. So the area of B over A in the velocity time graph should be equal to the area of this. So this area should be equal, the value of this area should be equal to this area. And we have to estimate that by looking at the graph. If we look at the textbook, we can see a precise, more accurate and precise graphical presentation of the graph, and we can see it that it's formed by a square, unit square. See, I will show you. Here is from the textbook. You can see here. Yeah, just wait. Here. See, this area, region, should be equal this value of this area, I mean the magnitude, should be equal here at what time here. So I'm guessing based on this by looking at the squares here. You can see all the blue part in the square should be equal to this. I'm guessing, just approximate, instead of estimate, is in 2.1, where we will have the same number and parts or quarters or fractions of the axis here. So around 2 here, around here, maybe somewhere greater than 2 should be more than the second minute. So that's my answer, and thank you for watching my tutorial video. Till next time.